Hello guys, this is a problem from the USAMO 2018. It says that for each positive integer n, find the number of n-digit positive integers that satisfy both of the following conditions. 1. No consecutive digits are equal, and 2. The last digit is a prime. Let's solve this. Let's define what a great number is. A number that has no consecutive digits equal and its last digit is prime. Let P of n equal to the number of great n-digit numbers. Our task is to find P of n. Let's define what a good number is. For n greater than or equal to, if it ends in a prime and no consecutive digits are equal among its first n minus 1 digits, then it is a good number. The number of good numbers is equal to 9 times 9 times n onwards and lastly times 4, which comes as 9 to the power n minus 1 times 4. Any great number is good, and if the last two digits are equal, then the good number is not great. We can see there is a bijection function from good to great. For n greater than or equal to, P of n equal to 4 times 9 to the power n minus 1 minus P of n minus 1. We subtracted the number of good numbers minus the number of great numbers up to n minus 1. We know that P of 1 equals to 4. The homogeneous part of this equation is P of n plus P of n minus 1 equal to 4 times 9 to the power n minus 1. The characteristic equation is r plus 1 equal to 0, so r equal to minus 1. Thus the homogeneous solution is pH of n equal to c into minus 1 to the power n. The non-homogeneous equation is a times 9 to the power n plus a times 9 to the power n minus 1 equal to 4 times 9 to the power n minus 1. So a equals to 2 by 5 and pp of n equal to 2 by 5 times 9 to the power n. We know that p of 1 equals to minus c plus 18 by 5. Thus c equals to minus 2 by 5. Therefore p of n equals to 2 times 9 to the power n minus 1 to the power n by 5, and our solution is complete. Thank you for watching.